Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. We're in the middle of a video series about completing the square. This is an algebra technique and a strategy to be able to rewrite equations in certain forms. The idea now in this video is problem set, and we're going to be taking equations in one form and rewriting them so we can graph the ellipse. All right. Let me remind you what completing the square is, though. And because this is a video series, if there's things that I'm talking about that are a little too far, you're not quite ready to kind of practice with me, go to my YouTube channel and search for things that are in that same title, completing the square, and you can kind of go back and review if you need to. But completing the square is being able to write the third term of a trinomial in order to make it a perfect square trinomial, and the goal is then to factor it as one of these. These are squared binomials. A lot of these equation forms with circles, ellipses, hyperbolas, and so on require a binomial squared. All right? So the idea is you take the middle term here and you take half of it and square it, and that's how you determine that third term. Half and then squared. All right? Pretty simple. You just have to recognize when to use it. So what we're going to do now is I'm going to try, have you try two equations right here, numbers 3 and 4, and I want you to rewrite these in standard form. All right, that will give us, for an ellipse, the center and the a and the b amounts, which indicate how wide and how tall the ellipse is. All right, now remember, just a little quick hint if you need it, you want to move that constant to the other side. Okay, so you can take a look at both of those there. Move the constant to the right and then group the x terms and the y terms together and complete the square twice. All right, I'm going to work this out, hit pause, give it a try. So the first thing we have to do is move that constant to the other side. So we're going to add 35 to each side, and we will have that. And then, of course, we want to group the x terms together and the y terms together. So 9x squared minus 90x, and then we'll have 4y squared minus 32y. Now again, a strategy is to look at the x terms and factor out a greatest common factor, GCF. And that looks like it would be 9. Alright, so inside the parentheses we have x squared minus 10x. Now we leave a gap because we're going to need to complete the square there with a third term. And then we look at the y terms. What can we factor out there? Right. 4, not 2, because 4 is bigger. So let's factor out a 4, and that will be y squared minus 8y. Again, leave a gap for the third term in our completing the square, and then it equals 35. So we complete the square here by taking half of the negative 10, that's negative 5, and then squaring it. Remember, it's half squared. So we add a 25 there, and half of negative 8 is negative 4, and square that, it would be 16. Now we have to balance this out, so whatever we added on the left side here in green, I have to add to the right. But remember that I added the 25 in here, so it's really 9 times 25. Alright? What is 9 times 25? Right, that's 225 that I actually added in right there. And this is not just a 16, but it's really 4 times 16. Okay, and that should be 64. Now I total these two numbers up, which is 289, and I'm going to add that to the other side. Alright, so whatever you added on the left side in green, you add to the right. Keep it balanced. To factor out our trinomial here, that would give us x minus 5, all of that squared, and this would be y minus 4, all of that squared. And these two numbers add up to 324. Now in the ellipse standard form equation, we have to have everything equal to 1. So we definitely need to divide everything here by 324. So I'm going to divide each of these here, these separate terms, by 324. And then notice the 9 and the 324, we have a common factor of 9, which is kind of nice. And that gives me a 36 in the denominator there. All right, let's factor out and cancel out the 4's there, and that'll leave me with 81 on the denominator. So finally, this is what our equation looks like. Right there. So when we look at that, being an ellipse, we know that the center of the ellipse is going to be at +5, +4. That's what that tells us. And the a value, which is horizontally how far from the center it goes in the right and the left directions, square root of 36 is 6. And 81, take the square root of that, is 9. That's the b value, so it's 9 going up and down from the center. All right, that's the value of being able to rewrite these equations. Now number 4, let's go over that and I'll show you how to work that. Alright, again, the first thing we do is we make sure the constant gets put on the right side so it becomes a positive 128. And then we group our x's and y's together. Now there's only one x term, it's x squared, so it's going to stay by itself. But now we have a 4 factored out of a trinomial we have to complete the square. So y squared minus 14y, half of minus 14 is -7, and square it. That'd be 49. Now remember, we didn't just add 49 over there, we added 4 times 49, which is 196. Now we factor out this trinomial here, which would give me y minus 7 squared, and it's 324. We want to have a 1 on the right, so we're going to have to divide each part by 324, and we're going to put it in under separate terms there. And now we have to do some canceling. So as you can see, this is our final answer. X squared over 4 plus y minus 7 squared over 81 equals 1. Now what that tells us, if we were to graph this ellipse, is the center is going to be at 0, 7, and the a value is going to be square root of 4, which is 2. The b value is square root of 81, which is 9. So it's 2 units wide right and left from the center, and it's 9 units up and down from the center, and that's the ellipse. Alright, thanks so much in this problem set 4, and the next series of videos, a set of videos, is going to be working on hyperbolas. Alright, thanks for watching. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live, online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard and take care.